So one of the big advantages of BERT is really to be able to learn the left to right and the right to left context of a sentence together, and it's learned by the same network. And this is done by applying self-attention, and we will see how that works here in a little bit. And then when you're building a BERT model, there's really two phases. So one is the pre-training, when you build the model and train the model from scratch. And then you can also take a pre-trained model and fine-tune it to your specific training data and also to your specific NLP task. And a task could be, for example, text classification. So there's two BERT models, pre-trained models, for example, the BERT base and the BERT large, which basically differentiate in the number of layers and hidden units they have. All right, so here's a quick overview of those two steps. So the pre-training, when you're training BERT from scratch on a large generic training data set, which could be Wikipedia, books corpus, etc. And then in that phase, BERT applies two techniques. One is the masked language model, where it randomly masks input tokens to predict it and to build up this language model. And in parallel, it also runs a technique called next sentence prediction to kind of understand whether one sentence follows the other. And those are applied in parallel. And this really is kind of the big advantages here next to the attention of BERT. And then in the second step, which is a supervised training, you basically fine-tune it to your specific data set. Let's say you're doing maybe text classification based on customer reviews, and you want to say, is it a positive review or is it a negative review, or you want to classify maybe in star ratings. All right, so BERT has created literally a BERT mania in the industry. So there's a lot of different fine-tuned models that are specific to a domain. Let's say clinical BERT to healthcare, SciBERT to scientific, BioBERT to biomedical language, etc. And there's also specific language models. Camembert is the French model, German BERT, German, and BERTje is the Dutch, and there's many more. So there's really a lot of different flavors of the BERT models nowadays. All right, so BERT under the covers. As with any NLP models, the challenge is to create the right input representations, because we can't just pass plain English text to the model. So we do have to create word vectors or word embeddings for the model to understand. And in the BERT terminology, there is sentence, and a sentence can really be an arbitrary span of contiguous text. It doesn't have to be actually a linguistic sentence as we know it. And then the sequence refers to the input token sequence. So once we've tokenized the raw words, and then those tokens are passed into the BERT model. Could be a single sentence or two sentences packed together. And then BERT uses word piece embeddings to basically tokenize a sentence. And word piece has 30,000 token vocabulary. And the task here is really to take the input words and tokenize them. And we will see in a bit how this looks like. It's also embedding some special tokens. So for example, CLS right at the beginning of each sequence. And if it's separating two sentences, if it's passing a sentence pair, those are separated by the SAP token. All right, here's a quick visualization of how this works. So if you're reading this bottom up, you can see that at the bottom I have my sentence. So I say, love this movie, right? This is a very short, casual expression of a customer review. And we run it through this word piece tokenization, and we can see the first special token, CLS, gets inserted. And then in this example, for example, I just split it by love, this, and movie. It could be that actually there's tokens that kind of look different. One word doesn't necessarily have to end up in just one token. There could be some stemming of the words, etc., going on as well. So for the ease of readability, I just tokenized with the full words here. All right, so in this example, we have one input sequence consisting of those 4 tokens. And then in the next step, we look up the token embedding for the token, which is a 768 dimensional vector representation. And here I have the ID pointing to that. Then the segment embedding is basically just saying whether in a sentence pair, it's the first sentence or the second. If I just pass one sentence here, it's 0. And then I also record the position of each token. So the first one encoded with the ID 0, and then the fourth one with the ID 3. And after that, I do an element-wise sum of those 3 embeddings of the token, segment, and position embedding. And this is basically my input embedding for the BERT model. Right, looking into the BERT model architecture, it's consisting of various layers. And here I zoom in into a single BERT layer. And you can see that there's a couple of components here. The most important one, which we'll show a little bit more in detail here, is the attention module. And this is really the implementation of this very famous paper that you've probably heard of, Attention is All You Need, that talks about how to apply this self-attention to a sentence to capture how the words are attending to each other. And then there's a feed-forward module, which basically contains all of the parameters, or most of the parameters, which is a fully connected layer in here. And then also some residual connections and layer normalizations. And this is basically a single BERT layer. And then after that, you would then apply another layer depending on your task or question answer or text classification. All right, zooming into a little bit here into the attention. BERT actually is a combination of various layers. So if you're using this pre-trained model, the BERT base, that has 12 of those layers stacked sequentially, and the BERT large would have 24 of them. And inside of those, and here we just focus on the attention module, basically. Also, we're talking in this context of attention heads, which is basically a single implementation of this attention mechanism. And per layer, I do have various of those. So it can be 12 or 16, again, depending on which model you're choosing. And the way this works is the BERT input embeddings get distributed to each attention head. And then basically it works through this attention, and the outputs are then summed up and passed to the next layer. So the model weights are also important to note, not shared between the different layers. And those multiple attention heads are really important if we want to capture a different meaning of a same word. And I do have an example here. Let's say Tom gives Sarah chocolates, and another sentence, Sarah gives Tom chocolates. So it's the exact same input tokens. And in this case, gives would have a same embedding if we didn't apply this multi-head attention. So by running those sentences across different heads, we're actually able to encode this. All right, so the attention is all you need. I do have a little bit more details in here how attention is calculated. But I guess in the interest of time, I want to show you how we can actually visualize that. So let me quickly go through. So first of all, BERT splits the inputs into 3 different vectors by applying a specific weight. So we end up from one input X, which is an embedding, in with a query vector, a key vector, and a value vector. So, and then the attention is calculated with so-called attention weights, which are the dot product of the query vector and the key vector. And if you're not familiar with NLP, that might be a little bit too much detail right now, so don't worry. Basically, what I'm going to show you is how we can visualize the whole thing. And for that, I go a little bit ahead. So how can we identify the cause of an incorrect model prediction later? And that's basically the ultimate problem we're trying to tackle. And one approach is we can visualize BERT attention to understand what the model learns, so how this attention gets learned. And there's a couple of views that we can see. One is called the attention head view. And this has been defined in a paper and also an open source tool that is called BERT. So the attention head view shows how the individual tokens attend to each other. And the model view shows kind of a bird's eye view of all of those attention heads across all the layers that I quickly introduced. So you could have 16 per layer, and you could have 24 layers in total. And so this is kind of visually showing all of them. And then the neuron view, which shows more details in those query and key vectors that are used to calculate the attention weight, which then is used to calculate the overall attention metrics. All right, so I'm gonna jump here quickly through, and I'm jumping into a demo. So I wanna show you how you can monitor and visualize bird attention. And for that, I'm jumping here into a Jupyter notebook. So I'm running this in my AWS account, and I'm using Amazon SageMaker, which is one of our managed machine learning services. And in here, I'm using one functionality, which is SageMaker Debugger, which lets us actually capture the tensors during model training. And when we have the tensors, we can then create those visualizations. So in here, I'm using Gluon NLP. So this is an MXNet demo. And I'm using a fine-tuned, I'm gonna fine-tune a pre-trained model on the Stanford question answering data set, and then use this SageMaker debugger functionality to monitor the model training. All right, so let's see how we do this. So first of all, I'm installing the SageMaker debugger Python SDK. And I'm pulling in here a couple of more SDKs to interact with AWS and SageMaker. And then obviously for the fine-tuning part, I do need a training script. So here's just a quick peek into this training script. So you can see we're importing MXNet, NumPy, etc., Gluon NLP. And I'm also importing BERT for Q&A, basically from this model zoo here, and also the question answer data set, and my debugger. I load the data here, I batch it, etc. And then here's the code to run the model training. Oops, sorry, I closed it here. To run the model training with all of the settings that we set here, etc. All right, so we do have a model training script. If you want to check this out, it's part of our GitHub repo. That I can share here in a sec in the chat, or Chris can maybe put it in. All right, so I'm sorry for the scrolling here. When I do have this training script, I can then start the training job. So here I'm creating an MXNet estimator in this environment. I'm pointing it to my training script, and I'm going to run this on a GPU-based instance, a P3 to X large, and passing in the hyperparameters here. And for the SageMaker debugger to work, I'm introducing a hook configuration, give it a path in a 3 to write out all of the results. And to collect, I define here that I want to collect all the tensor information. This is a predefined package. And I'm going to say include regex. And here I'm defining the specific regex to capture the multi-head attention from my BERT model as well. All right, so I'm gonna train the model, and I can check where the output data is stored. So it's a bucket here in my S3 environment. And I get the training job name, check that it's finished. So I've executed this notebook before, so we don't have to wait for that job. And I can then create a trial which consists of all of the tensor outputs. And here you can see I'm just printing those tensor names. So you can see here the BERT encoder, the transformer, the multi-head, so all of the information. And then I'm loading bokeh to visualize, and I'm reading in the tensor information. So first of all, the tensor name. So you can see I'm working here with 12 heads. And here's the output, reading in the tensors. Then also I'm going through the different layers. And I captured the input token so we can actually see the words. And with that, I can start visualizing. So to visualize, I use a script that can plot this in the tool Bokeh here in the Jupyter environment, which I'm calling. So the script, if you're interested, is also part of the GitHub repo. And I pass in the input tokens, the tensors, and the layer information. And here we go. So here I do have a visualization of a single attention hit. And you can see by the lines, the darker the line, the more it attends to that word. So in this case, country attends very strongly to what, and the other words you can see here as well. All right, so you could flip around. So here you can see the different layers, which you can flip, and the different heads per layer, and which step of the epic of the training run. And as a last one here, I can also visualize the neurons. So those are really kind of low-level detail now from the query vectors. So I'm reading in my query vector. And here you can see how that looks. A lot of numbers. And I'm reading in those key vectors. Again, a couple of numbers. And with that information, I can then build this element-wise product and the dot product. And I can visualize again with a script that is preloaded here. And here's the result. So this is the neuron view. And in this case, I selected this input token what. And you can see here in those individual visualizations, the darker that line is, that neuron actually caused the prediction. So, or it attended to that word, better said. And you can see here the darker the dot product results here, the more it attended. So this one here, what attended very strongly here to this token, mens. So yeah, and you can flip here again through those different query tokens and the different layers. All right, this was a very, very fast view how you can visualize BERT attention. Flipping back here to my slides. SageMaker, I showed you the debugger use in here. And I just want to show a last slide. So the problem is attention really enough to explain a poor prediction? And probably not, because visualization shows you where the words attend to. But ultimately, I think for explainability, you need a little bit more information. And there's another framework, LNLP, which tries to help you explain prediction, especially in the context of NLP models. And just quickly, here's a screenshot. They have a live demo online where you can put in sample inputs. In this case, I used it to do a sentiment analysis with the Roberta model. And I passed a sentence, I love this movie so much. And it's been classified as positive. And what you can see here, it's a gradient-based approach, which is suited better to explain classification predictions, such as sentiment. And you can see here, it's applying 3 different techniques, gradient visualizations, and it's pointing you to the exact top 3 most important words that led to that prediction of positive. All right, and that's pretty much what I had here. Couple of links as well. And this was just the first slot. So with that, I'll stop my share here. And I'm super happy to welcome Brittany today. And she's going to take it from here. So Brittany, the stage is yours.
Perfect. I will just share my screen quickly. Oops. And there we go. So I'm really excited today to talk about these curated reading lists that I've been creating. So there's not a great visual for these, so if you want to check these out while I'm talking, this is the link. But when I'm creating these resource lists, reading and resource lists, the things I focus on are finding correct, current, and inclusive content. And these lists are lists that provide links to resources for people to learn about a particular topic. So, you know, I've done one on AWS IAM, I've done another one on VPC, and my latest one is on Amazon SageMaker. So before I get into each of these lists and the qualitative and quantitative data about them, I'm going to go through about why I'm creating these lists and how I create content. And I see there's a question in chat and which folder. It's just the one folder, and you can kind of go through there. And each of the lists cover one specific topic. So the background on why I've been creating these lists is because a few years ago, I was studying for a certification in the information security field that I thought would really help my career, because that was my focus at the time. And I thought the certification would also be helpful because I'd asked friends how to boost my career. And they said, you know, look up what other people have done and follow their example. So I looked through the Twitter timelines of people I looked up to. Most of them had posted their resumes, and you could see this one certification on it. So, you know, I was excited. I was able to find the materials to study for that certification on a Humble bundle. And so I had a plan. I could get this certification. Unfortunately, several months later, and after I'd finished studying the materials, someone had started a Twitter thread ripping the certification to shreds. They mentioned how many factual errors the study materials had and how meaningless the certification was overall. And the people that I had seen that had the certification were also ripping it apart, and they were saying that sure, they had the certification, but only because it was the only way certain companies would accept them to work on certain projects. They never recommended to anyone otherwise. So I was kind of crushed. I'd spent months studying for something that I thought would help my career, but instead I ended up studying things that were incorrect. And the worst part was that I didn't know which parts of the materials that I read were incorrect. So it sucked. This experience is not an isolated incident either. So I've heard from many other people getting started in new fields and new topics that they've been in similar situations. Someone tells them to look something up, they follow the advice, they read on the topic, and they end up learning information that might not be correct or current. And, you know, some of these people have said how much it has hurt their careers because they end up making major mistakes at work. So to combat this issue, I've started this project to create and curate public reading and resource lists on a variety of topics so that people looking to learn something new can have a place to confidently begin their self-directed study. And right now I only have a few lists, but I'm just getting started. So now let's talk about how to create these reading and resource lists. So far, I've got it down to about 6 steps. And the first step is the easiest: pick a topic. And these topics can come from a variety of sources. Like the first one I picked because, you know, I just started a job with AWS. I came from a security background, and so I felt like, you know, AWS IAM would be a great place to start. And for other lists, I've gotten topic suggestions from coworkers, developers, and people have taken the time to message me on Twitter or through email requesting lists on specific topics. The second step is to collect resources to review. This usually involves doing a web search, looking on YouTube, scouring blogs, looking on social media, and all over. And at this point, the goal is just to collect resources related to the topic that can be sorted through and curated later. And it's important to note that as I carry out my research, I actively seek out content in as many formats as I can find. So video, audio, demos, walkthroughs, everything. And this helps to ensure that the people reading my list can learn via the format that suits them best. And I also do my best to make sure that I get sources from a variety of authors so people can see themselves in the people that are part of each community's topic. The third step is to actually curate the resources. And this is where the bulk of the work happens. I spend a lot of time on this step because I am so meticulous, and I want to make sure that people can learn confidently and not feel like they might be learning something incorrect. And part of the reason this takes so long is because I go through each resource multiple times. And as I review content, I'm looking to verify 4 different things. I want to know that the content is open access, that it's inclusive, that it's correct, and that it's current. Determining whether a source is open access usually involves opening up a browser that I don't use very often, ensuring that I'm not logged into any services through that browser, and seeing if I can access that resource without traversing a paywall. If I can't access the content on a clean browser, I remove it from the pool of potential content to feature. And I really care about featuring open access content in my lists, as many people, for many different reasons, can have trouble affording content that exists behind a paywall. And with my reading and resource list, I am actively working to provide a curation service for anyone wanting to learn, regardless of their circumstances. So inclusivity takes work. I only accept resources that use inclusive language into my list. Additionally, I try to ensure that videos come with subtitles or closed captions, and that podcasts and audio content come with transcripts. If video subtitles or audio transcripts aren't available though, I may still add the resource to the list, but with a note stating the lack of accessibility alternatives. Evaluating the correctness of a resource list is the most time-consuming part of this process, because I do my best to go through each resource line by line and verify what's being said. And to verify a resource, I compare what was said to official documentation, or I'll follow along with the demonstration myself to make sure every step is easy to understand and that it's definitely possible. Or I get an external review from a subject matter expert if I'm not quite sure on whether a resource is correct. Then judging whether a resource is current involves determining whether there is an immediate use case for the information at hand. For example, one of the resources I reviewed for a list was open access, it was inclusive, and it was correct for the time in which it was made, but it was a walkthrough that taught people how to set up a new AWS account, and it focused on a version of the AWS console that has not been widely relevant for about a decade. So now that we've collected and curated the resources, the 4th step is to prepare the list to be posted. For each resource that has passed my checks, I create an entry in my list that includes the title of the resource, which you can see at the top here, the authors of the content and or guests or speakers. So if it's a YouTube video, I'll say, which company posted it, and then I'll actually do the research to see who actually talked in the video so I can feature those people as well. Then I post the relevant link, how long it should take somebody to get through the content if that information is available. And then I also provide an itemized list of what knowledge readers can expect to gain from ingesting the resource, which you can see by the bullet points here. And if applicable, I also add the notes of accessibility options underneath that. And I really believe that providing the time it takes to get through the content is important, because this information will let people know whether they need to block a considerable amount of time out of their schedule, or whether they can absorb the content in a few free minutes while they're waiting for somebody at the door, or waiting for the takeout food, something like that. Additionally, I provide an itemized list of content covered in each resource so readers can judge whether the resource is actually worth their time or not. For the 5th step of creating these lists, I post the reading and resource list publicly. The primary place I post my lists is on GitHub, but I also try to make them available through blog posts and my personal website, just in case somebody's not able to access GitHub or whether they don't want to. And then my favorite step is the 6th and final step, which is incorporating feedback back into the list. The reading and resource lists are really only as good as long as they're useful to the people that are reading them. And anyone is welcome to contact me via social media or email, GitHub issues or pull requests, or in person once it's a safer action, to give me feedback on what they want to see added, removed, or changed in regards to these lists. I'm here to listen and help people out. And so far, the Prominent type of feedback I receive is lists people would like to see in the future or types of resources they would like to see added to these lists. But I really hope that as I continue these lists, people will start to suggest additional resources that they have either found or created that they would like to see highlighted. So now let's talk about some quantitative and qualitative data. Some of the things I collect while I'm creating these lists are, how many resources I've reviewed, how many resources passed my checks, and how many didn't. It's also, I really like looking at the common reasons why I reject lists or reject resources to be on my list. And then the last one is there's some cool trends that I'm able to see in these resources. So like I said previously, my first list was on AWS IAM, and I was able to review 19 resources. I only accepted 9 of them, 10 were rejected, so more than half. And finding these 19 resources and reviewing them and going through them, making sure they're great, took me about a month of work time. So it's about 1 resource a day that I'm able to get through. For the 10 resources that I did reject, it was for these reasons. One video had such distorted low quality audio and no subtitles that it was basically unusable. Like no one could actually listen to it and get data out of it in a way that was easy and comfortable. Same thing for some of these videos having extremely loud music playing throughout them. Like if I can't hear what you're trying to say over the drum and bass, it's not a great resource. It's hard for people to hear, especially if you don't have subtitles. And then of course we have the same issues of, there's language that was not inclusive. We had the 1 resource that was not current, and that was that console I was talking about later. And then we had 6 resources that contained inaccurate information that were just straight out lies. The second list I created was Amazon VPC. And again, 10 resources, 5 accepted, 5 rejected, and I only spent 2 weeks on this. So it was the same average of about 1 per day. The 5 resources that were rejected here were for containing incorrect information again, really bad quality audio that people couldn't listen to. And then I had a new problem of resources requiring excessive unrelated background knowledge. There were just a couple resources that were part of a series and that I wanted to include in, and I would have considered the entire series, but there were other videos in the series that contained incorrect information. So I couldn't recommend everything overall. So this one resource, or these 2 resources that had this unrelated background information, I couldn't really support them being part of the list. And lastly, the third list I've worked on is the Amazon SageMaker list, and 4 resources reviewed, but I only spent a week on this one. So again, about an average of a resource a day. And again, the videos had distorted low quality audio. They had one had excessive audio processing to the point where I have one friend help me out. They have an auditory disorder, and when they're watching videos it can really affect them badly, and this one video with excessive audio processing actually caused them to get extremely angry and have a strong emotional response to it. And those are exactly the types of videos I want to avoid on these lists. I don't want anyone to feel uncomfortable while they're ingesting this information. And again, we had the issue of language not being inclusive. So let's talk more about the qualitative stuff. These 6 videos from the IAM list that had incorrect information all contained the same incorrect information. Each one of them had the same sentence of AWS IAM roles are only for services and no one else can use them, when in fact, users can adopt IAM roles as well. And so, they all had this inconsistency. And this is exactly why I'm making these lists. Is, some people, when I tell them about my issue with the certification and the information is wrong, they say, well, why didn't you just listen to something else? Why didn't you ingest another resource? And the fact is I did, but you still don't know if these other resources are correct. And when you look at this problem, you know, I had reviewed 19 resources for my AWS IAM list. A third of them contained the same incorrect information. So it's that issue of repeated mistakes that, you know, I'm hoping to avoid and make sure people don't run into if they read these lists. The next major issue with these lists is, with finding resources for these lists, is a lack of quality and inclusiveness. Every one of these lists I ran into resources that did not use inclusive language, so I didn't include them. But also the audio was a lot bigger problem than I thought it was going to be, especially for recorded things that, you know, people can edit or change or redo before posting. A lot of people don't, and then you end up with these videos that can cause strong negative emotional responses, or that can just leave people who want to ingest the resource unable to because they can't hear anything. The next thing is, there's actually an issue with homogeneous resources. So many of the things I look at are videos. I just find videos, that's about it. I can't find anything else. I've been trying to find more blog posts, walkthroughs, other things that people can do open access. And it's been hard. You know, almost all of our learning is done through video now, but I have people specifically approach me and request more blog posts. So I'd love to see, you know, more variety in how we learn going forward. And the last issue with my list is the time intensiveness. Like, it is taking me, you know, a day per resource at this time. And I'd like to speed that up. And, you know, one way I'd like to see that is, you know, seeing more feedback from other people. So that brings me to kind of the end here, which is the call to action. Please give feedback. Like, if you do read these lists and, you know, you enjoy them, or you want things changed about them, or you want a topic, let me know. This is the only way I can make things better, is by hearing from all of you about what you would like to see. And of course, create content. I would love to feature your content, to see what other people are creating. There's definitely not a lot of intro AI stuff out there that explains a lot of the tools easily or does basic walkthroughs. I would love to see more of those. So yeah, like, let me know if you make something. I would love to feature it. And so thank you very much. Again, my name is Brittany, or if you're looking for me on the internet, I'm usually called Strafe. And this is my link for the reading list. Thank you very much.
Perfect. Thanks so much, Brittany. Excellent. People really enjoyed that insight in how you're creating those lists. All right. So with that, I'm handing over straight to Kashif. Kashif, are you with us here?
Hi there. Yep, so let me go ahead
Perfect.
and share my screen real quick. Can you hear me okay?
Yes, audio is perfect.
All right, cool.
And with that, the stage is yours. Welcome.
Let me share my screen. All right, cool. So, all right, hi everyone. My name is Kashif Imran, and I'm our Principal Solutions Architect in AWS AI. Specifically, I work in our AI CV services team. We have a couple of services around recognition and text extract and so on. So topic for today is you know, really customized image and video analysis. But before I jump into that, I just wanted to quickly start with you know, the AI ML stack, which I'm sure many of you are familiar and have probably seen you know, by other presenters in some of the other sessions from AWS. So the AI ML stack at AWS, you know, it has three layers. You know, the bottom layers, where again, kind of given the audience, I think in this case, we have many developers, but a lot of folks I think are really into, you know, the data science and really machine learning practitioners. So the bottom two layers really provide you a wide variety of services to support your end-to-end machine learning journey. So from ingesting your data, you know, cleaning up, transforming the data, building your model, training your model, deploying, and then having continuous feedback to improve your models. You know, there is a whole range of services there. The focus for next about 15 or 20 minutes or so is going to be the top layer, what we call is the AI services. And the idea here is, here at AWS, we solve many of the common problems. We train machine learning models for those. We deploy them in highly available, highly scalable environment. And you as developers can pretty quickly use APIs and SDKs to take advantage of those machine learning models to build intelligent applications. A common question I get here is, that's great. It's awesome for developers to quickly to build that. How does it help, for example, if I'm a data scientist? So a lot of times, even as a data scientist, when you're building these solutions, you can think of these AI services and these teams as sort of extension to your team. So maybe, you're building a complex solution. For example, maybe you need to do, some document processing where you need to get some text and then do NLP on top of that. Instead of trying to build the whole solution from scratch, you could use something like Amazon Text Tract, which gives you, text and all that, and then you can do NLP on top of it, or combined with services like Comprehend. Focus for today is Rekognition, which, as I mentioned, is the deep learning image and video analysis service. So I'll just quickly jump into some of the core features that Rekognition provide. Where we have a wide variety of APIs, so things like Labels API, which gives you object, scene, and activity detection in images, and activities comes in video. Custom labels, what then allows you to customize Amazon Rekognition and detect objects of your interest, specific to your business needs. There are things like content moderation, facial detection, search, celebrity recognition, and wide variety of services, including text detection. Let me quickly give a quick demo to get some better understanding. It's easier to visualize it compared to just talking about it through slides. So here, if you go to AWS console and go to Amazon Rekognition, you can see these different APIs in action pretty quickly. You can bring in your content, whether it's image or video, and see how some of these APIs work. So in this case, for example, I'm looking at the Labels API, which returns different objects and scene information, and returns basically a list of labels along with some confidence score. And for many of these labels, we also return bounding box information. So you can as developer build interesting applications using that information. Similarly, there is Image Moderation API, which again lets you detect offensive content in both images and videos. And here we'll return a hierarchy of labels, and not just a Boolean flag saying whether it's safe or not safe, because what content might be considered safe in one part of the world may not be safe, considered safe in another part of the world. So we return a whole list of labels, including things like whether there is explicit content, suggestive content, violence, and so on. And then depending on that, as a developer, you have the control to then mark that content safe or not safe. Similarly, there are other APIs around facial analysis, celebrity recognition, as I mentioned, and things like text detection and so on. And there is also a section in the console where you can try some of the videos and again see how these different APIs work for your videos and so on. Now that's great, and people really love the ease and use of these APIs. But one of the most common requests that we have been getting is, how can I easily, for example, let me just switch to this slide so you could understand. Like here is some example of labels. So if you send these pictures to Amazon Rekognition, it returns you labels like machine part. But a lot of times, it would be a lot more interesting if you could do things like, for these images, it could detect things like, the first image is a turbocharger, the second is a torque converter, and the next is a crankshaft. Similarly, you send labels like these to Rekognition Labels API, you get something like a logo or icon or symbol. It'd be a lot more interesting if you could actually detect whether this is an EC2 logo or S3 logo and so on. Similarly, for animated characters, if you send this to Rekognition, you get something like comic, but it'll be a lot more interesting, and you can build more useful applications if you can really detect that there is Arthur and Buster in this image. Similarly, around classification, here are some examples of leaves, which Rekognition Labels API will tell you. But you might want to detect that the first one is the damaged cucumber leaves, second one is the infected, and maybe the third one are the healthy leaves, and so So again, as machine learning developer, as data scientist, you can do it yourself. Usually it requires tens and thousands of images, a lot of expensive, it can be time consuming, and it can take a lot of time because you have to acquire those large amount of data sets and go through the whole training process and so on. So this is where Amazon Rekognition custom labels comes in and help. And the idea is you can have customized image analysis to really identify the objects of your business domain. And you'll see that the custom labels really provide you a guided experience. So you can easily bring in your images, quickly create training and evaluation set. And then as your model is ready, you can use very simple to use APIs to then take advantage of that. So with your labels, instead of generic labels, you can get specific labels that you need. Let me quickly switch to the console and show you a quick demo to understand how custom labels work and what the end-to-end flow looks like. So for the demo, what I'm going to show is, let's say if you have an image like this, and you call it the labels API, you get some generic labels. But what our goal is to be able to detect these animated characters in the images. So this is what the end-to-end workflow is going to look like. Whenever you need to, for a specific problem that you're looking to solve, you're going to collect images for that. So in this case, because I want to detect those animated characters, I would go and collect, pictures of those animated characters. Next is you bring those images into Amazon Rekognition custom labels, and you create a training set, and you create a test set. You then ask custom labels to go ahead and train a model, which is then going to start a training job. Once your model is trained, it's going to run some evaluation and provide you those evaluation results. Once you're satisfied with the evaluation results, you can just deploy that model and then consume it using, whether AWS CLI or APIs and so on. So let me switch to the Rekognition custom labels console. So the idea here is when you come to the custom labels console, you'll see there are two options. You can create projects and you can create data sets. So data sets is, obviously as the name suggests, this is where you bring in your content that you're going to be using to train the models. And projects is the container for your basically project where it will contain all the models and all the other artifacts specific to the problem that you're solving. So let me go ahead and create a data set. So you come to the data set, click on create data set. I'm going to give it some name. Let's just call it random name. And you get a couple of options to bring the images. You can, for example, if you're already using SageMaker ground truth, you could just import images from there. If you already have a data set and custom labels that you have prepared, you can just copy that. You can import images from an S3 bucket, or you can upload images from your local machine. So in this case, I have some images in an S3 bucket that I'm going to use. Let me actually quickly switch to another tab where I have that S3 bucket open. So you can see in this case, what I have done is for each character that I wanted to identify, I have put a couple of pictures for each one of them and put them in different folders. And the idea here is when you come to custom labels, let me take the path to that S3 bucket. So here you say, you see I selected the import images from S3 bucket. I give the name of the location here, and I can select this checkbox for automatic labeling. What this is going to do is, because I have my images already put in different folders, it's going to take these folder names and automatically label my data set. So in that case, it can save you some time from the data annotation process and so on. At the bottom of the screen, you see some permissions. So this is what AWS console needs on your S3 bucket. I've already copied this and pasted it into my S3 bucket access control list. So I'll just go ahead and hit submit. So what this is going to do is this is going to go and get those images from that S3 bucket, bring them into the console here, and then I can go ahead and easily add any further annotation that I need, you can see in this case, it automatically labeled 8 of my images. Only one is unlabeled, which I intentionally left this image outside of these folders. So you can see that one is unlabeled. All the other images, have automatically been labeled. Let's say if you have an object detection use case, you can, quickly annotate your images here. So let's go ahead. I'll just select one image and click on Draw Bounding Box. So in this case, console really gives you a guided experience. I can easily select and do all of this work here. I can select the character name, draw the bounding box, click done, and save changes. So this helps you quickly prepare your data set. Once your data set is ready, the next step is you go to projects. You can click on create a project. Just give it a name, create project, and then you can come and click on train new model. So the training a model basically require 2 inputs. One is the training set. So I can just choose, the training set we just created. And the second thing it needs is our test set. So you can either, choose an existing test set that you have created. You can create a new one if you want, or you can use the option to split. So what this is going to do is it's going to do an 80-20 split. So 80% of the images are used for training, and 20% images are used for the test set. And then you just hit train. I have already trained a model. So let me just quickly switch to that one and show you real quick what the final output looks like. So in this case, you can see I have a model that got trained. I have my training and test set. It shows you different things like, let me click on that. So you can see it gives you that evaluation result where it provides you the information such as F1 score, precision of your model, recall of your model, as well as getting at the per label performance. So you can see how each one of your labels are performing and whether you need to maybe bring in for more images for different labels and so on. You can also click on view test results and it provides you information for each image in your test set to show you how each one of those are doing. You can see things like true positive, false negatives, and get some idea how your model is performing. And then based on that, use different techniques to further improve the performance of your model. Let me quickly show you how do you then can do inferences. So in this case, I'm just going to use a UI demo that again is linked from the Rekognition custom labels documentation. So with this model trained, I have deployed this UI. So I just come here. I can click upload and just select one of these sample images. So you can see while it's run the inference, so see it's detecting these different objects as well as giving me the bounding box and confidence score. And if I go back to the model, you can see the cool thing was I was able to use a very small number of labels. Like I had about 47 in the training set and 9 images in the test set. How do you use this? Again, the goal is as a developer. So let me just show you a quick sample, and you'll see it's a very, very simple to use API. So the idea is this sample shows you I have a document or an image in my S3 bucket. So here is the name of the bucket. And then the model that you train, when it gets deployed, it gives you a project version on. So project version on is basically referring to an endpoint of the model that's your custom model. Then rest of it looks pretty straightforward if you're familiar with the labels API, for example. All you do is, in this case, I'm using the Python SDK. So you just create a Rekognition client, and then you can call the detect custom labels API. You provided the endpoint where your model is. You give it the image that you want to process, and how many number of maximum results, for example, you want to get returned. It gives you a response back with all the labels that got detected, and then you can just iterate over those. So let me just quickly run this. Let me quickly run this. So you can see we got the same labels along with the confidence score and so on. One last question I just want to address, because I've seen that's a common question, like, okay, you know, I have trained my model, but maybe I also want to process videos, for example. So you could use, you know, something like, there are tools such as, you know, FFmpeg, or, you know, use OpenCV or any of those to do some frame extraction. So here we have a sample image, a code sample, again, listed in the aid custom labels documentation as well. And the idea is, here I have, again, a quick sample video. I'm using this project version on, which is the endpoint of the model that I showed you earlier. You create the Rekognition client. You just use OpenCV to get the video, you know, capture those frames. Once you get the frame, again, it's, you know, the simple example as we saw earlier. You call the detect custom labels API. You can pass the image, in this case, frame as a raw byte, for example. Pass this endpoint, get the results back, and then you can process those. So that, you know, was a very, very high level, you know, quick overview of custom labels. And the idea here is, it really helps you to very, very quickly, you know, customize Rekognition to your business needs. The cool thing is, as you saw in that overall process, you don't need to have any machine learning expertise. So, you know, as developers, they can quickly get started. And machine learning experts, you know, can take advantage of this, where you don't necessarily need to bring in, you know, lots and lots of training data set. You know, instead of tens to hundreds of thousands, you know, you can bring, you know, maybe tens of thousands and still able to train a model. Similarly, you know, customize image and video analysis in hours instead of spending, you know, weeks or months. And it's fully managed service, so you are very easily able to take advantage of this, you know, using APIs and take advantage of the service being highly available, highly scalable, and secure, and so on. With that, looks like I'm out of time. So, you know, thank you. I'll switch it back to the team.
Yes, thanks so much, Kashif. We had a lot of questions here coming in. So maybe I just read one or two out. We're trying to address them here. So yeah, people are interested generally how you can use Rekognition specifically in the medical domain to help classify X-ray images, etc. So if you have any thoughts on this one. The other topics were how many samples do you generally need to train a model? And I already quickly said, like, it's very dependent on the use case. If you're training obviously from scratch, if you're using a pre-trained model, etc.
Yeah, so let me address quickly, you know, one or two of these. I know we're over time. So, you know, it's a very common question I hear, you know, how large the sample data set should be. And as you rightly said, you know, it really depends on the problem. But the cool thing about custom labels, what I usually suggest is, you know, start small. You know, don't try to get, you know, tens and thousands of images or, you know, thousands of images. You can always start small, very quickly, train the first version of the model, see how the model is performing, depending on, you know, the labels or objects that you're interested in. I didn't get a chance to show you what we call is a feedback solution. So again, it's listed from the documentation from custom labels. What that feedback solution helps you do is, once the first version of your model is trained, let's say, you know, you need to bring in more labels, right? So maybe you get a few hundred additional labels or a few thousand additional labels. Instead of going through manual annotation, you can just use that feedback solution, which basically calls the first version of your model, get the inferences, and then start a labeling job. And the idea is, let's say if your model is performing, let's say maybe 50%, it means 50% of your images would automatically be annotated. And that way you're only doing just corrections and so on. So quickly prepare V2 of your data set, and then you can train the next version of your model. So basically use the versions of your model to assist you to improve the performance. So that kind of helps there. Again, now whether it's coming back to the other question around medical images or some of the other examples, I think it really comes down to, you know, again, exactly what you are trying to detect in some of those. And given that it's very, very easy, you know, I highly suggest, you know, just grab a few images and see the performance that you're getting. You know, and if you need more help, you know, absolutely reach out to your account team. Would love to work with you and see, you know, how custom labels quickly help you, you know, get and solve the problem that you're looking for.
Yes, and I think there's a final question here on how would you deploy the model on an edge device? Do you have to do model compression there?
So today, when you use custom labels, they get deployed in the cloud, so you don't have the option to deploy it in the edge. If that's something you're looking for, would love to get more feedback on what are some of the problems there. But today, those models get deployed in the cloud.
All right. One question is coming in: scratches, damages. I guess the question is, can it be used to detect scratches in iPads, TVs, etc. on screens?
Right. Again, it's an interesting problem, right? It depends, what how much, the detail, like how deep the scratch is and so on. So it really comes down to, what at what level you're trying to identify that. So you should definitely be able to try, custom label for that kind of problem.
All right, I think, let me see. Yeah, I think that's the questions we had here. So thank you very much for joining us today, and thanks again to Brittany and Kashi for this great presentation. Quick summary. If you want to have a little bit more hands-on, you can join our hands-on workshop we're running this Saturday. So Chris and I will be hosting that, where we're showing data science on AWS end-to-end, from the data ingestion to creating the pipelines. And feel free to sign up. We do have a few spots left for the Saturday, a full day, and you're getting a Sandbox AWS account, so you can try out all of those services. And with that, thank you very much for joining us today, and hopefully see you in the next session. Thanks so much, everyone.